Hello, my name is Felipe Jung, designer and leader of the team Momentum Robotics.
Our presentation is about the recent explosion of AI in the market. In this sense, a billionaire called Steve Works created robots called Maria and Minnie to adapt to the market. Maria is capable of communication with humans and robots, as well as interaction with her surroundings.
Hi, I am Fernando Nakazuni, and I am responsible for the robot mechanic.
And I am Ricardo Braga and responsible for the 2D and 3D modeling, as well the PCB confection.
In the first version of the robot Maria, we built a structure with a trash can. Her arms were made out of PVC pipes, and the supports were printed in 3D. This version was presented at the Latin American Robotics Competition, LARC.
For our RoboCupJunior, we improved the Android using Autodesk Fusion 360 software to design the three-dimensional sections of Maria's head, base, neck, and the motor supports of her arm. This time we 3D printed the parts we needed for the project. Since the base and the neck sections were quite large, we had sliced them into multiple pieces to be printed separately.
To do the torso, we use an MDF structure to create a more resilient and cheaper support.
Next, we created a multi-layered egg structure to withstand our use. By applying a combination of glass fiber and resin, we are capable of pulling something beyond our own expectations.
For the finishing touches, we use polyester putty to create a surface to use automotive paint to give the final appearance. To pull that off, we received help from a car painting company that teaches techniques to properly apply the paint.
We used Autodesk Eagle. Next, by utilizing a copper attaching through the FECL2 technique, we generated the circuit on the board. One of our biggest issues was the size of the robot, meaning that trying to print on a 3D printer was not viable due to its cost and time. To solve this, we opted to cut its parts into equal fragments, so the printing process would be faster. To make it less expensive, we replaced Maria's body with MDF and coated it with glass fiber and polyester putty.
Another problem encountered was the organization of the wires. To address the issue, we mapped them for easier identification. We used a laptop to be the processing center for the robot, which communicates with an Arduino Mega via USB cable using serial protocol. The laptop sends a signal to the Arduino Mega that distributes the same signal to the electric, servo motors, and the DC motors that are all controlled by 8 bridges, which are all connected to the PCB. The Arduino is also responsible for sending commands to the wire ZigBee module to another ZigBee that is connected to the Arduino Uno of the mini robot. Upon receiving a signal, this mini robot, which is inside the Maria base, moves forward and activates 2 servo motors.
Hello, I'm Gabriel Pedrosa.
And I am Fernando Nishio.
We are responsible for programming hardware using wiring.
And also we're responsible for the development of artificial intelligence using Python. Calculate 9 plus 7.
The answer is 16.
Recognize.
Read the count.
Control the robot's actuators and establish the communication between Arduinos. We've utilized both Python and the C++ based wiring language. Through efficient, failure-resistant coding, we were able to, among other things, make Maria track objects and move her arms. In order to track objects, Maria uses a camera to read the target's object's position with the help of AI. Then, the laptop calculates the movement Maria should undertake with her head so as to correctly orient herself with respect to the target. The instructions are then sent to and done by her actuators. The movement of the arms features the help of a highly sophisticated position-seeking algorithm. With the help of transformation matrices and vector additions, we calculated virtually all positions achievable to Maria's arms, allowing her to independently decide at runtime which position she needs her arms to be in, grab the corresponding angle triplet, and execute it with her arms. Finally, we have also used several techniques to ensure Maria would be as resistant to failure as possible, such as breaking down codes into independent modules, enforcing redundancy in robot-to-robot communication, and enabling her to retrack a target should it briefly escape her field of view.